Hello friends, welcome to engineering tutorial. So we'll continue our discussion with maximum power transfer theorem with the circuits involving dependent sources. So this is the 8th question which we are going to discuss. This is the circuit diagram and we have to find the value of this load resistance such that maximum power is transferred to the load and the value of that maximum power. Here the important thing to consider is this current dependent voltage source, and this is the important parameter, the dependent variable, the current flowing through the 6 ohm resistor. Okay, so first we have to find the Thevenin voltage, the Thevenin equivalent circuit approach. We'll go through that. So redrawing the circuit, open circuiting this load resistance. So it is 3 ohm, 2IA, 3 ohm, this is 10 volt. This is 6 ohm, this is 5 ohm. This is open circuited. Now, because this is open circuited, as a result of that, no current will be flowing through this 5 ohm resistor. This is VTH, Thevenin voltage, and as there is no current flowing through this 5 ohm resistor, so no drop, here the voltage will be VTH. This is IA. So another important thing to notice is that this VTH is actually equal to 6IA. Okay, VTH is equal to 6IA, or we can write IA is equal to VTH by 6. This is important. Okay, now here when we apply KVL in this direction, this closed loop, we can write the KVL equation as this: 10, this is IA, minus 3IA plus 2IA minus VTH is equal to 0. That implies 10 minus 3 into VTH by 6 plus 2 into VTH by 6 minus VTH is equal to 0. This is 2, this is 3. That implies 10 is equal to VTH plus VTH by 2 minus VTH by 3. Okay, that implies 10 is equal to, taking LCM, so it is 6 VTH plus 3 VTH minus 2 VTH. That implies 60 is equal to 7 VTH. That implies VTH is equal to 60 by 7. Okay, VTH is equal to 60 by 7. So in decimal form it will be 8.57 volt. Okay, it is 8.57 volt VTH. So we have got VTH. Now we have to find RTH. So we have calculated VTH is equal to 8.571 volt. Now we have to find RTH. So for that we have to redraw the circuit, deactivating all the independent sources. So this 10 volt will be short circuited. So that is, redraw the circuit. And short circuited then we have this 3 ohm resistor, then this 2IA current dependent voltage source, then 6 ohm resistance, then 5 ohm, and then we have to connect an external excitation which is 1 volt. And the important thing here is to find the value of this current coming out of this 1 volt voltage source. Okay, and this is the important variable, which is IA. Okay, so this is the whole thing. Let us say that the voltage here at this node is V. So we'll be using nodal analysis. Okay, so let us assign the current directions. Let us say the current is flowing here in this direction. This is I flowing in this direction towards the node, and this is the outward flowing current IA. Here IA is equal to V by 6 and I is equal to 1 minus V by 5. These are two important relationships to bring the whole equation in terms of V, this node voltage. So here the equation is, the nodal equation is 2IA, this voltage, minus V by 3 plus I, okay, this current, is equal to IA. Okay, this is the Kcl equation. Now we'll substitute IA with V by 6. So here 2IA will be 2V by 6, which is basically V by 3. V by 3. Again, IA here will substitute with V by 6 and I will substitute with 1 minus V by 5. So the whole equation we have converted it in terms of V, this node voltage. Now it is easy to handle it. So here it is V by 3 minus V, which is equal to minus 2V by 3, which is equal to minus 2V by 9. Okay, V minus 3 by V, which is minus 2V by 3. Yes, minus 2V by 9. Then plus 1 by 5 minus V by 5 is equal to V by 6. So here we'll bring all the V's in one side and the constant on the other side. That implies minus 2V by 9 minus V by 5 minus V by 6 is equal to minus 1 by 5. So 1 by 5 came to this side, V by 6 came to this side. That implies here the LCM here is the common, I think it is 90. Yes, 90. 5, 90, yes, 6 is also 90. Yes, 90. 90. So it is minus 20V minus 18V minus 15V is equal to minus 1 by 5. That implies, let us erase this portion. That implies minus 38 minus 53V by 90 is equal to minus 1 by 5. So minus minus got cancelled. That implies V is equal to 90 by 5 into 53, which is equal to, let us determine, 90 divided by 5 into 53, which is equal to 0.3396 volt. Okay, so we have got V. I is equal to 1 minus V by 5. Okay, so I is equal to 1 minus 0.3396 by 5, which is equal to 1 minus 0.3396 divided by 5, which is equal to 0.132 ampere. 0.132 ampere. Okay, RTH is equal to 1 volt by I. Okay, RTH is equal to 1 volt by I ampere, which is equal to 7.571 ohm. Okay, 7.57 ohms. So this is RTH. So we have got VTH, we have got RTH is equal to 7.57 ohm. Now we can easily find these two things. We know, as per the statement of maximum power transfer theorem, for maximum power to be transferred to the load RL, this value should be equal to RTH, which is equal to 7.57 ohm, and the maximum power that is transferred is equal to VTH square by 4 RTH, which is equal to 8.57 square by 4 into 7.57, which is equal to, let us calculate, 8.57 square divided by 4 into 7.57, which is coming around 2.425 watts. Okay, 2.425 watts PRL max. Okay, so we have got VTH, we have got RTH, and we got PRL max. So this is the 8th question related to dependent sources maximum power transfer theorem application. So I hope you like this videos, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.